And now I call for the next presenter, Dr. Abdulrasoul Al-Omran from Saudi Arabia. تفضل دكتور.
Assalamu alaikum wa rahmatullah. Thank you, Mr. Chairman, and thanks the organizing committee for giving me this opportunity to present our work. Actually, Dr. Munir took most of the time to, and he took, same work that we are working. He talked about the water conservation and producing the biochar, and the only thing that he missed is the salinity. I think but anyway, my presentation, the title, the use of biochar to improve the hydrophysical properties. It is a completely different aspect. That what we need to work on it in Saudi Arabia, how to conserve irrigation water. And one of the methods that I've been working on it on improving soil physical properties to keep the water in the root zone if it's possible. So that's the goal of my talk, and the goal of using biochar as a soil amendment with other soil amendments, compost or polymers or clay deposits. I've been working on this for the last 30 years as water conservatives. How can we really conserve water with that? Is it possible? This is the questions that we're gonna. Which one, the red or green? Okay. It's not moving. Appreciate that. Shukran. الأحمر. سو الأحمر. إيه خلاص. من البداية؟ إيه لا من البداية. دعم. من البداية جمع الآخر. يرجع. Okay, thank you very much. I don't wanna repeat what Dr. Munir and yesterday Dr. also mentioned about Saudi Arabia in Arid region, and most of the water being used in agriculture, almost 90%. And most of the agricultural soils in Saudi Arabia is sandy soils, calcareous sandy soils, and these have some concentrations or negative signs, such as low water holding capacity, excessive deep percolation, high infiltration, low water use efficiency, and so. So my main focus on this is, can we improve irrigation water management in these soils? A previous finding or early research we done on that using the polymers, chemical polymers, and organic matter and the clay deposits. Honestly, I found the clay deposit is most useful one and the cheapest method to use to improve the soil physical properties. And lately, as adding soil amendment can increase water use efficiency and decrease water loss during the irrigation. Can we use the biochar? Actually, biochar has been introduced to the department by my student, and now my colleague in soil science department at King Saud University. He's a soil chemist, so they are working on carbon sequestration of the carbon in the soils. And we asked him, can we use it also to work on physical properties? And this is what initiated, that was 8 years ago. And since we are working on different methods of using biochars in order to improve soil physical properties. The use of biochar has been examined by us on improving hydraulic properties of the soil. Depend on so many factors. I'm going to list these factors actually in the biochar: temperature, amount, rate, so many particle size, how much you added. Is it nanoparticles, small particles, macroparticles, which will affect all the result of saving water. The soil amendments include the organic and inorganic, improve the soil properties, resulting in better condition, enhance soil aeration, soil infiltration, enhance water holding capacity. And so I'm going to go fast because already Dr. Munir talked about that. The palm trees in the kingdom. This is a photo from my region. I'm from Al-Ahsa, so that's, although I'm working here, but this is what they do actually in Al-Hasa. That was in the past time. They collect all the residue of the date palm, and then they burn it in the field. And this, we call it and I tried even my relative to switch to biochar rather than, we call it a tabina in our region. That's but still it's very hard to convince the farmers because they use it. They say this is will get out of the insects and many things that we use it as a nutrient. So when we do the tabina, so this is actually what is. And we started our research in a small in the lab, in a small furnace, as you can see. And this is biochar production in the field. This is what we have in the field, as you can see from the last photo on down. Huge containers to produce the biochar, and then we crush it and bring it to grind it to less than or 2 millimeter and less for the application of the biochar in the field. This is some of the characterization of biochar that we have. I don't want to stop here because this is already repeated yesterday and today in the morning. But you can see at different temperature you will have different also characterization of the biochar. Here, for example, the EC and the pH, as you can see, it's very high. It's 8 and 9 and 11, while the EC is acceptable. Some literature will say that the EC is over 10, but this is what we found in our research. What we are looking for in soil physical properties related to soil water, what we should measure, what are the parameters that we should do in order to say, well, this will give a good sign or negative sign for using the biochar. Mainly the water holding capacity. Can these materials, after mixing it with the soil, will hold the water, and water infiltration will reduce or decrease the infiltration rate of the sandy soils, and saturated hydraulic conductivity will be less. Water retention and plant available water and bulk density, aggregate stability, all these parameters should be done as a soil physical properties. It should be also to compare whether the biochar that we are using or the effect of biochar is useful, or can you use a biochar or not. The factor influencing the biochar itself is pyrolysis temperature, and many people talked about the temperature. Is it better 200, 300, 500, 600, and so, and the rate or the amount that we add the biochar to the field or to the columns that we are using. Placement also, where do you put it? Where do you put the biochar that you have? Do you put it on the surface or underneath? And how deep? And this is all when so many experiments that we gone through to reach to a better conclusions. One of the main factors is the particle size of the biochar, which size that you